Hello students, now let's see the properties of rational numbers. We have 5 different properties. These properties we have already seen with natural numbers, whole numbers and integers also. So the same properties. So first I will list out all the properties. What are the properties? First property is closure property. Second one is commutative. Third one is identity. In identity we have both addition and multiplication. And the fourth one is associative. And the last one is distributive. So these are the 5 different properties which we are going to see in rational numbers. In this video, I am going to explain only closure and commutative property, and the remaining 3 properties will be in my upcoming videos. So now let's start about closure. I'll explain you in a simple example with natural numbers first. 1 is a natural number plus 3 is a natural number. The answer 4. 4 is also a natural number. When I add 2 natural numbers, the answer should also be a natural number. Then I can say addition is closed, or closure property is true for addition of natural numbers. The same thing let's see in rational numbers. 3 by 4 plus 2 by 4. 3 by 4 is a rational number. 2 by 4 is a rational number. When I add, I will get 5 by 4. So 5 by 4 is also a rational number. So addition of rational number is closed, or closure property is true for addition of natural numbers. Now let's see for subtraction. 4 by 5 minus 3 by 5. What will I get? It's 5. 4 minus 3 is 1. So this is a rational number, this is a rational number, and the answer I got is also a rational number. Now let's check for multiplication. 3 by 4 multiplied by 1 by 2. The answer is 3 by 8. So all the 3 are rational numbers. Let me check for division. 4 by 6 divided by 1 by 3. First step, have the first fraction as it is. Change division to multiplication. Step number 3, change the second fraction to the reciprocal. Reciprocal of 1 by 3 is 3 by 1. Now I can cancel. 1 times 3 is 3 and 2 times 3 is 6. So the answer is 4 by 3. So in In all these four cases, in addition, subtraction, multiplication and division, my answer is only a rational number. So I can say addition, subtraction, multiplication and division of rational numbers are closed. So I am going to prove commutative property of addition of rational numbers. So I have A plus B in my LHS and B plus A in my RHS. If both the sides are equal, then I can say commutative property is true for addition of rational numbers. So my LHS, RHS, my number is 1 by 3 plus 2 by 6. So here I should have 2 by 6 plus 1 by 3. First I will find the answer for my LHS. My denominators are different, so I need to find the LCM. I know LCM of 3 and 6 is 6. So I need to change both the denominators as 6. Now to convert 3 to 6, I need to multiply by 2. Here I need to multiply by 1. So my answer will be 2 by 6 plus 2 by 6. So if I add, what will I get? 4 by 6. Same way, here also the LCM is the same, so I don't want to go with the LCM. So I'll get 2 by 6 plus, I need to change my denominator as 6. So I multiply by 2. It's 2 by 6. The answer is 4 by 6. So my LHS is equal to RHS. Therefore, A plus B is equal to B plus A. That is, commutative property is true for addition of rational numbers. Commutative property is true for addition of rational numbers. So now let's move on to subtraction. I need to check whether 1 by 5 and 4 by 10 are commutative under subtraction. Same way, I'm going to split into two columns. Let me take as LHS and RHS. So I need to check for subtraction. So what I have to prove, A minus B is equal to B minus C. I need to check. I don't know whether it is same or not. Let us check. A minus B and B minus C. What is A here? 1 by 5 minus, what is B here? 4 by 10. And here B is 4 by 10 minus 1 by 5. And the LCM of 5 and 10 is 10. I need to change the denominator as 10 for both the fractions. 5 times 2 gives me 10, so I multiply both the numerator and the denominator by 2. So it is 2 by 10. Here it is already 10, so it is enough if I multiply by 1. It is 4. Now if we subtract, what will I get? 2 minus 4. Both are having different signs, so I find the difference of 2 and 4. Difference of 2 and 4 is 2. And the denominator is 10, and the greater number is 4, is having minus sign, so the answer is minus 2 by 10. Now let me check the RHS. Here also the same LCM process, so you don't want to worry about the LCM. So I'll get 4 by 10 minus 2 by 10. The denominators are same, I have as 10. Now 4 minus 2. 4 is bigger number with plus sign, so 4 minus 2 is plus 2. Here I get minus 2, here I get plus 2. So I cannot say these two are the same. That is, LHS is not equal to RHS. LHS is not equal to RHS. That is, A minus B is not equal to B minus A. Therefore, commutative property is not true. Subtraction of rational numbers. Let's continue with multiplication. As we saw, addition of rational number is true with the commutative property, but the subtraction is not true. Now let's check whether the commutative property is true for multiplication of rational numbers. So we have seen commutative property of addition and subtraction, as we proved through examples that commutative property is true for addition and commutative property is not true for subtraction. Now let's check whether it is true for multiplication or not with these two numbers, 2 by 5 and 3 by 7. So as usual, I split into LHS and RHS. In my LHS, I should have A, B, and in my RHS, I should have B, A. So what is my A? 2 by 5 is A times 3 by 7. Let's find the answer for this. As I said, for multiplication, denominator need not to be the same. And also we should multiply both the numerator and the denominator. 2 times 3 is 6 and 5 times 7 is 35. So let's check what we get in RHS. My B is 3 by 7 times, and my A, usually take the first number as A and the second number as B. 2 by 5. So 3 times 2 is 6, 7 times 5 is 35. So now I get both are equal. That is, my LHS is equal to RHS. AB is equal to BA. So I can say commutative property is true for multiplication. Now let's move on to division. As usual, take two sides. This makes our work easier. So what should I prove? What should I check? I can't say it as a proof because I don't know whether it is true. A divided by B in my LHS and B divided by A in my RHS. If these two are equal, I can say commutative property is true for division. I am taking this as A and this as B. So 3 by 6 divided by 4 by 5. Step number 1, have the first fraction as it is, 3 by 6. Step 2, change division to multiplication. Step 3, write the reciprocal, 5 times 4. Now I can multiply both the numerator and the denominator. 3 times 5, 15 by 6 times 4, 24. It is not necessary to simplify because we are going to only check. It is not needed. If you want, you can change it as a standard form. So now let's move on to RHS. My B is 4 by 5 divided by 3 by 6. Have the first fraction as it is, 4 by 5. Change division to multiplication and write the reciprocal of the second fraction. Now the answer is 24 by 15. Both the numbers are the same, but the fraction is not the same. Both are different. My LHS is not equal to RHS. That is, A divided by B is not equal to B divided by A. So commutative property is not true for division of rational numbers. Okay, now let's conclude the commutative property. Commutative property is true for addition and multiplication, and it is not true for subtraction and division.